After having discussed in this week how to authenticate by means of passwords, we have seen there is a great variety of attacks against such password. Password authentication looks not so secure. So we want to discuss in this video more secure ways for authentication. And one important idea is our so-called one-time passwords. And the idea behind is that a password can only be used once for authentication. That means if one has already used that password, one will never get access to the system, to the service by means of that password. The password immediately lost its validity after the first use. So even if an attacker has intercepted or spying out this password, it's useless because he cannot use, because password can be used only one time. But of course there's a problem. The user must be provided with a list of such passwords. For each login, a new password, a new one-time password is needed. So it's much more difficult than to work with one password. Typically, for this purpose, to provide the user with a list of some one-time passwords, an independent second transmission channel is necessary. For example, by a hardware token. The RSA Secure ID token is a famous example. Or by a text message, for example, via mobile phone, such MTANs, lists sent per post or others. Such TAN lists, these are lists of such one-time passwords. An even more secure way and more convenient way for authentication is authentication by means of public key cryptography, by means of public keys. The application of public key cryptography methods are the following. The user gets assigned not one key for decryption, the user gets assigned a key pair. There is one so-called public key and another so-called private key. The idea behind is that the public key can widely distributed. Everyone who wants to get in contact with me can get my public key. But my private key, I never have to give to another party. So it's a big difference to the usual cryptography, cryptographic methods, the secret key methods, where there is one key which is shared between the two communication partners. Here, in case of public key, where each user has two keys, the private key remains only with the user and the public key can freely distribute it. For a secure authentication, a user needs a certificate and he needs his or her digital signature. What is a certificate? What is such a digital signature? A digital certificate is something like an ID card. It is issued by a trustworthy entity which confirms that there is connection, a link between the identity data and the user and his or her digital signature. So, like in the case of an identity card, a government administration gives this. Here we need such a trustworthy entity, for example, a trust center, which states that the public key and the user are connected. Like in an ID card, the photo and the name is connected to the person. The digital signature, this proves the identity. This proves that the identity data actually come from the user. This digital signature is comparable with the handwritten signature, but it's modelized by cryptographic methods. The user, which gave his signature, his digital signature to a message, proves that this message really comes from him or her, and that this message was not faked or was not manipulated on the transmission way. So for a secure authentication, the user needs the digital signature. This is the service characteristics encrypted with the user's private key. There are data like name, like other things that are important, and it is encrypted by means of the user's private key. So digital signature is a special encryption scheme that is run, or this is performed by means of the private key of the user. The certificate, which is also needed for a secure authentication, consists of identity data and the public key of the user. And this both things provides a possibility for a secure authentication. But it's important that the identity data and the public key are in some sense authorized. And this authorization is given by the trustworthy entity, by the trust center, by digitally signing this identity data and the public key. So everyone can control, because the signature is encrypted with a private key. It can be decrypted with a public key. Everyone in the net can check whether this is a digital signature of the trustworthy entity, of the trust center, and when the person believes in the work of the trustworthy entity, in the work of the trust center, then he gets the public key of the user together with his identity data. And then, based on the digital signature of the trustworthy entity, everyone can recognize, yes, that's true, this user, to this user, that public key is belonging. For now, a secure authentication with a service, user send their digital signature together with a certificate. Digital signature together with a certificate. No password is sent, no password is logged in by working with the public key mechanisms. The digital signature and the certificate is sent to the service. So the authentication service of the service provider checks first the certificate. We speak of verifies the certificate. It does it by encrypting the digital signature of the trustworthy entity with the public key of that trustworthy entity. And then, if it's possible to decrypt, then it's clear it was signed by the private key. And then the authentication service can see the name of the user and can see his public key. So the certificate is only valid if the public key of the trustworthy entity fits. That means it's possible with the public key of the trustworthy entity to decrypt the certificate and to see the content. And the certificate is only valid if the certificate's decrypted entity data match to the user's signature. To the user's signature, identity data decrypted with the user's public key from the certificate. Certificate part was a public key, and by means, if it's possible, by means of the public key to decrypt the signature of the user. Remember, the signature was given by was an encryption by private key. Then the authentication service can be sure that the user is the right one and can authenticate the user. Here, let's have a look to a picture which shows what we are doing. We have the user that wants to authenticate. We have the authentication service in the internet who wants to check whether the user is really the user and whether the user has the right to use the resources of the service. And then there is a third party. This is the trust center, the trustworthy entity. And these three parties cooperate in the following way. In the beginning, our user needs a certificate. In order to get a certificate, it asks to get a certificate from the third party, from the trustworthy entity. And the trustworthy entity checks the name of the user, checks his identity data. There are different ways, for example, that the user is forced to show his identity card, or there is another mechanisms. And then the trustworthy entity issues a certificate. There is written the identity data of the user and the public key of the user. And this is signed with the signature of the trustworthy entity. Signed means that's encrypted with the private key of the trustworthy entity. Now our user has a certificate. And when the user wants to authenticate, he sends the certificate and signs this certificate. That means he uses his private key and encrypt the certificate and other information that are important for the authentication with his private key. This is sent now to the service, the verifying user. And the verifying user needs the public key of the user to decrypt his or her signature. So what the verifying user is doing, he receives the public key of the trustworthy entity, and by means of the public key of the trustworthy entity, the verifying user can decrypt the certificate. In the certificate, there is a connection between the name, the identity data of the user, and the public key of the user. And then by means of this public key of the user, then he can decrypt the signature of the user, and then the verifying user is sure that is a user which has an account with the service and which is allowed to use this and that resources. This signature, this public key authentication, this public key encryption is really a little bit difficult. It's based on strong mathematical algorithms, but I hope you have got the idea that by means of the two keys, the one key which everyone only is with one user, and the other everyone can use. It is clear if something is encrypted with the private key of a user, and if it is possible to decrypt this with a public key of that user, then one is sure the user was the only one who could send this message and who could sign this message in this way. There are more ways for secure authentication. So there is it possible to use smart cards. This is a quite convenient way. The user's certificate and signature here is simply stored on a smart card. And the smart card itself is protected with a PIN. So the private key can thus only be accessed by means of the PIN. So the user needs the card, the user of the smart card needs the card and needs to know the PIN. So there are two factors which are needed before the private key can be used and known. So there are new identity cards, for example, in this way. Only smart card owner can use the certificate. And here, I remind you that we said authentication is considered secure if it's based on two factors. On two factors, in this case, it's the knowledge of the PIN, and it's ownership of the smart card. In case of passwords, which were considered as an unsecure way for authentication, only one factor is valid, and this is the knowledge of the password. So two factors here with the smart card authentication is property and the knowledge of the PIN.